The unit that we're starting now is a geometry unit that will center on proofs and definitions and axioms and postulates. And basically, it goes back to the days of Euclid, who was the first to really systematize this axiomatic approach to building a system of geometry where he starts with a very few definitions, a very few unproven theorems called postulates, and then everything else is built from that. And basically, that's what we're going to be using as the method that we will employ for this geometry unit. So the couple of definitions that it starts with, and they're really things that are considered to be undefined, but they can be described. And so the first is a point, which has 0 dimensions. A line, which has only 1 dimension, extends infinitely in both directions. And a plane, which has no thickness, has 2 dimensions, and extends infinitely in 2 different directions. And so those are the basic elements that everything else is built out of. And then there are what Euclid called 5 postulates that were the foundation of his system. The first is that a straight line segment can be drawn joining any 2 points. Any straight line segment can be extended indefinitely in a straight line. Given any straight line segment, a circle can be drawn, having the segment as radius, one endpoint as center. All right angles are congruent. And then the fifth one, which many people thought could be proven over the years, although no one ever has, and that is through any given point can be drawn exactly 1 straight line parallel to a given line. And that postulate was actually worded differently by Euclid, but it's been reworded a number of times. And there are geometry systems where that theorem does not hold. Those are called basically non-Euclidean geometries. So let's just take a look at some of the elements here. So we have the points A and B. We have line AB, which goes through the 2 points here. And these 2 points determine a line uniquely. We then can call that line either AB or BA because it goes in both directions. And it's drawn, the symbol is drawn with 2 arrows on either end. And when we draw lines, we'll draw 2 arrows on either end of the line. This particular software does not do that. So we can then add a third point. So A, B, and C are collinear, which means they all lie on the same line. And then we can draw what we call a ray, which is part of a line, and it starts at a given point and then extends infinitely in one direction. So the way that we name that is we can call it ray CA, where C is the endpoint and the ray passes through point A. We could name it by any point. Then we could also have ray CB, which starts at C and passes through B. We also could have what's called a segment, which is where we have just a connecting, in this case, point C and B, and we call this segment BC or CB. We're naming it by the endpoints only. And this has a finite length, although it has an infinite number of points. Okay, so we also, when we have this ray, we can create another ray, let's say this ray here, and this ray has the same endpoint as ray CA, and together these two form an angle, and that angle is angle ACD. And so we say an angle consists of the union of 2 rays which have a common endpoint. And then this particular angle has a measure, which is 37.41 degrees it was. And there are, when we move this thing around, we can see that once we go past 90 degrees, it goes from being an acute to an obtuse angle. And when we set it at exactly 90 degrees, it's called a right angle. And then there's also such a thing as a straight angle, which is when the 2 rays form a 180 degree angle, which is to say that the rays are opposite rays. They have the same endpoint. They lie on the same line, but they extend in opposite directions. And that forms a straight angle. When we add other rays here, we can see that we now have 4 rays, and together they form 2 lines. And these 4 rays form 4 different angles. And as you can see here, we have 2 green angles, 2 red angles. The 2 angles that are opposite each other are going to be congruent. That means that they have the same measure. And the two red angles are also going to be congruent. They have the same measure as well. We can see that angle, the green and red angle here form a straight angle, so they add to 180, as these two do as well. So the two red angles have to have the same measure. So these are vertical angles, and one of the things is when we have two angles that together form a straight line, those two angles are called a linear pair. So the green and red angles would form a linear pair. They're also supplements of each other, which is to say that their angle measures add up to 180 degrees. Two angles that are supplements do not have to lie in the same line. So here we form another angle that has the same measure as the red angles up here. And so that means the green angle, ACD, and this angle at H here are supplements because their measures, 40.88 and 139.12, add up to 180 degrees. They are not, however, a linear pair. So going back, we also want to talk about when we have, let's say, we have segment AB, and we can create a midpoint on that is going to be exactly halfway between those two. And so that will always divide the segment into two congruent halves. And so we say we have bisected this segment. We also want to talk about when we have an angle, we can bisect an angle. And in order to do that, we have another angle that is exactly halfway, a ray that goes from the same endpoint and cuts angle ACD into two congruent parts. So the angle AC going along this ray and DC going along this ray, these two angles are congruent to each other, which means that we have bisected this angle ACD. So I want to talk just a little bit about the idea of intersections and unions as it applies to geometry. But first, I'll just take a quick look at how we do it with sets. So let's say we have the set S, which has the elements 1, 2, 3, 4, 5, and the set T, which has the elements 4, 5, 6, 7, 8. The union of those two sets is the set of all elements that are in either S or in T. So that would be 1, 2, 3, 4, 5, 6, 7, 8. You notice 4 and 5 are not counted twice. We only count each element once. The intersection of S and T is the set of elements that are in both sets, so those would be the sets 4 and 5. So when we talk about that in relation to geometric objects, we say, all right, let's say we have ray CA and ray CB. Well, right now the intersection of these two rays would just be point C. The union of these two rays would in this case be the line that goes through the A, C, and B because the two rays are on the same line. When we add, let's say, this other ray, we would say that the union of rays CD and CA is the angle here. The intersection of rays CD and CA, again, would be just a single point, point C. If, for example, we said, let's look at these two, and let's call now ray CB. Well, now since C is the endpoint, the ray starts at C and goes through B, and then ray CA also starts at C and goes through A. So in this case, ray CB and ray CA are the same ray. So the intersection of the two would be the same as the union of the two because they're identical. On the other hand, if we look at ray BA, then we'd say the intersection of ray BA and ray CA would be all the points that are on both, which would be just the ray BA. The union of CA and BA would be ray CA because all the points on CA are either going to be on ray CA or on ray BA. So those are some of the basic ideas. Just a couple other things here. When we have two lines, let's say, that are crossing like this, these two lines, when they're not forming a right angle, are called oblique. When they are forming a right angle, the two lines are called perpendicular. The one other thing that we'll see the other relationship lines can have is that they would be parallel, which is to say that we might have a line that passes through E that is parallel to AB, and we can create that here. So no matter what happens, line AB and the line through E are parallel, so they will never meet anywhere.